Hello everyone, today we'll be talking about defining and using sequences. So first, for some vocabulary, a sequence is an ordered list of numbers, and we have two different types of sequences that we can see. The first one is a finite sequence, and this is a function that has a limited number of terms and whose domain is the set 1, 2, 3, all the way to n, however many terms there are in that. So for example, a finite sequence would be the sequence 2, 4, 5, and 8. This one, the domain is just 1, 2, 3, 4, because that is the amount of terms that we have. And the terms of the sequence are the values in the range. So I see here my domain for this example sequence was 1, 2, 3, and 4, because that's how many terms I have. The range would be the actual values. So looking at this same example, my range would be 2, 4, 5, and 8. And then another type of sequence we have is an infinite sequence, and this is one where the function continues without stopping and whose domain is all integers greater than 0. So for example, I could have the sequence 2, 4, 6, 8, and then I see this dot, 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 and this dot, dot, dot means that it continues. I'll make a note of that. And we see that sequences can be specified by an equation or rule. So if I'm looking at that same example, 2, 4, 6, 8, I see that pattern is all even numbers. And so I can specify that by saying a subscript n is equal to 2n, or f of n is equal to 2n. So let's look at some examples of looking at those rules. So for these examples, I'm going to write the first 6 terms of the sequence. And so I'm given the rules. So number 1, I'm given that a sub n is equal to 2n plus 5. I want to write the first 6 terms of the sequence. So to write the first term, I need to plug in the domain starting at 1. And so I can say a sub 1, which just stands for the first term, is equal to, here, everywhere I see an n, I'm replacing it with 1. So instead of 2n, I have 2 times 1 plus 5, which just equals 7. And do the same thing with 2. So now I have a sub 2, which stands for my second term, is equal to 2 times 2 plus 5, which is equal to 9. And I can keep going on. And this is going to equal to 11. A sub 4 is equal to 2 times 4 plus 5, which is equal to 13. A sub 5 is equal to 2 times 5 plus 5, which is equal to 15. And then a sub 6 is equal to 2 times 6, which is 12, plus 5, which is 17. And so that means my first 6 terms of the sequence are 7, 9, 11, 13, 15, 17. Okay, let's try another one. So here it's written a little bit differently. I have f of n is equal to negative 3 to the n minus 1. This is the same thing as if I were to write a sub n here. It's just showing it in a different format. And so the first term is still going to be starting when n is equal to 1. And so I have f of 1, which here, just to illustrate this point, I'm going to use a different color, is equal to negative 3 to the n minus 1. But here, instead of n, I'm going to replace that with 1. Well, 1 minus 1, I get 0, so this becomes negative 3 to the 0. And anything to the 0 power is just equal to 1. And then continue on. So I have f of 2 is equal to negative 3 to now to the 2 minus 2. Or sorry, 2 minus 1. Which is equal to negative 3 to the first, which is just equal to negative 3. f of 3 is equal to negative 3 to the 3 minus 1, which is equal to a positive 9. And then I have negative 3 to the 4 minus 1, which is equal to negative 27. Negative 3 to the 5 minus 1, which is equal to 81. And then negative 3 to the 6 minus 1, which is equal to negative 243. And so that means my sequence here is going to be 1, negative 3, 9, negative 27, 81, and negative 243. Okay, let's look at one last one. So here I have a sub n is equal to n over n plus 1. So I want to write my first 6 terms, and so I'm going to start with n equal to 1. So I have a sub 1 is equal to, everywhere I see an n, I'm replacing it with 1. So I have 1 over 1 plus 1, which equals 1/2. A sub 2 is equal to 2 over, now 2 plus 1, because everywhere I see an n, I'm replacing now with 2, which is equal to 2/3. A sub 3 is equal to 3 over 3 plus 1, which is equal to 3/4. A sub 4 is equal to 4 over 4 plus 1, which is equal to 4/5. A sub 5 is equal to 5 over 5 plus 1, which is equal to 5/6. And then a sub 6 is equal to 6 over 6 plus 1, which is equal to 6/7. And so that means my first 6 terms of the sequence is 1/2, 2/3, 3/4, 4/5, 5/6, and 6/7.